Okay, so we're looking at the quadratic formula and the discriminant. And we're going to be given something in standard form, and this is our quadratic formula. That piece is called the discriminant. So the b squared minus 4ac has a special name. And it has different properties. And that's what we're really interested in, is what happens when that is 0, what happens when that's positive, what happens when that's negative. And how does that relate to solutions, and then how does that relate to graphs? So that's kind of what we're looking at. All right, there's three possibilities, right? It could be bigger than 0. That gives me two real solutions. So that just means that I have something under that square root that I can take a square root of and get a real solution. There's no negative values. And that's where the plus or minus comes in. If it equals 0, how many solutions am I going to have? One, right? It's b, negative b plus or minus nothing. So it doesn't matter if I add or subtract anything to it. It's going to give me one value, and that solution is going to be negative b over 2a. Okay? And that's a real solution. And if it's less than 0, what type of solutions am I going to get? Two. What type of solutions? Two real solutions? No. Imaginary or complex, right? We're going to be taking the square root of a negative number. So I'm going to get two complex solutions. I'm going to have an imaginary component to it. All right, so that's pretty straightforward. If it's greater than 0, I'm going to have two real solutions. If it equals 0, I have one real solution. If it's less than 0, I have two complex solutions. What I want to take a look at real quick is what these real solutions could look like. So I could have rational or irrational solutions. What's a rational number again? All right, we'll do it again. All right. What's the smallest set of numbers? Natural numbers. Good. What are those numbers? 1, 2, 3, blah, blah, blah. The counting numbers, right? What comes next?
Whole numbers.
Integers. Okay, what are those? The naturals plus the negatives plus 0. Alright. What's next? The what?
Irrational.
Irrational? The rationals. And those are the fractions. Alright, what comes after that? The irrationals. So that's the square root of something. Those are its own set. And then I get the reals. And then I get imaginary or complex.
Wait, so are integers and natural numbers rational?
Yes, that's a great question. So remember our Venn diagrams, how they work. We don't do them enough in math class. Are the integers and the natural numbers rational?
Yes.
Yes. What's the denominator? 1. Or, so if I take the number 2, I need it as a fraction. It could be 2 over 1. What else could it be?
4 over 2.
4 over 2. 6 over 3. It is a fraction. It could be expressed as a fraction. It's just not reduced. So the rationals, integers are rationals. Rationals don't necessarily have to be integers, right? And then the irrationals plus the rationals gives me the real numbers, and that's where you would stop for your whole math career. And then 2 weeks ago we talked about this, right? The complex numbers. So if we introduce the negative square roots, then we get the whole number set, and that's it. Until somebody comes up with something else, that's our set of numbers. All right. So if I wanted a rational value here, what do I need to know about the discriminant? What type of number is it going to be?
Real.
It is going to be real. It's going to be greater than 0. two words. One begins with a P, one begins with an S.
No hints.
Alright, so we could do like hang this up.
Yes.
I need, this is an integer, yes?
Yes.
Yes. This is an integer, yes. This needs to be an integer. So when I take the square root of something and I get an integer, that is a special name, two words, P and S.
Perfect square.
Thank you. Yes, perfect square.
Go.
Alright, so if it's rational, that means that the discriminant is a perfect square. Alright, are there lots of perfect squares? It depends on what you think about lots. There's infinitely many, but they don't happen very often, right? So we have 1, what's the next one? 4, 9, 16, 25, 36. If that pops out in the discriminant, you're going to get a rational solution. Alright, if you get anything else that's greater than 0, that's not a perfect square, you're going to get some irrational thing. Alright? So if it is a perfect square, it works out all nice. And that's what most of the problems that you've done before worked out at. But more often than not, you're going to get some square root of 13 or something, and then it's going to give you an irrational solution. Alright, so really 5 things that can happen. 3 of them are real, 2 are complex. Alright, thumbs up if you're still good. Good. Alright, what does this look like graphically? So if I took something like that, there is a parabola, something squared. Show me on your fingers how many real solutions that has. See, not a lot of voting here. 10. All right, let's take a step back. Who can tell me what it means to be a root? What's a root mean? You put it in and you get out what? 0. So if I take a value here for x, I put it in and I get out 0 for y. How many points on this graph do I put in something and I get out 0? 4? 2.
Well, it's doing like
Here.
gotcha.
Here and here, right? So it has 2 real solutions. It intersects twice. It's going to have 2 real solutions. All right? Do we know if they're rational or irrational? Not unless you could read that scale. So if it crossed at a rational number like 2.5 and 8, it would be. But we can't tell from my graph because it's long. All right, so it has 2 real solutions, 2 real roots. That has 1 real root. So where it just touches at one point, okay, it's going to have 1 real solution. So that means that the discriminant is going to turn out to be 0. All that's left is no real solutions. Can anybody think of what it's going to look like if I have no real solutions? Okay, it could be, that could be turned. It could be above it. Okay. Remember, if we think about what does it mean to have solutions or roots, it means where it crosses the y-axis. So if I have no real solutions, this is going to be no real solutions, 2 complex solutions. It could be up there, or it could be down below. The key is that it doesn't cross the x-axis. There's no real number that you can plug in and get out 0. And the reason it doesn't show up here is because we don't have any place for I to show up. And so when you guys go down the road into pre-calculus, you'll have a graph that looks like x and I. You'll have an I that you can plug in and you can graph the complex numbers. Alright, so big idea for the day. Crosses it twice, 2 real solutions. Hits it once, 1 real solution. Doesn't hit it at all, no real solutions, but 2 complex solutions. Alright, in terms of our discriminant, that means that we were bigger than 0. That means we were equal to 0. And then what does the last one mean in terms of the discriminant? Less than 0.